I'm going to tell you exactly what we need for today's project. And before I do, I'm going to tell you what this is going to do.
Okay.
We're going to create something tonight that is going to light a light whenever Category 5 Technology TV is live on the air.
Ooh.
Ooh, okay.
And when we sign off, it's going to turn off the light.
Yes.
You can place this device anywhere in the world as long as it has an internet connection. You're going to build it yourself. We're going to do it with a Raspberry Pi and a couple of little
We'll tell you when
peripherals.
we're live.
It's going to tell you when we're live. So I'm going to jump over here. I've got a little bit of walking to do, so talk amongst yourselves while I get over here.
This is great.
I
This
feel
is
like
what we
a
need.
Great reminder.
Okay.
Yes.
This is what we need. Now there's a Raspberry Pi in behind here with Ethernet cable plugged into it. I've got the T-cobbler. This is an optional component, but it really, really helps to be able to connect everything together. And it shows you the pin assignments, which are really, really helpful. We're going to need one LED. We're going to need a 330 ohm resistor. Can you folks see that there?
Yep.
And then we're going to need a couple of cables to wire it all together. Very, very simple circuit. And you can see how I've wired this. So first of all, the LED, so just note that the longer leg is going to be your positive. So that's going to go into pin 18, which is 3.3 volts. All right, so that is I've already connected everything together just for the sake of the show. So the longer pin is going into pin 18, and then the shorter end of the LED, which is the negative, also called the cathode, that is going to go to the lane that has the resistor. So what the resistor is going to do, and it's focusing on my hand rather than the, that doesn't really work very well. So what this is going to do, let's grab a screwdriver here. So the resistor is going to prevent too much power from coming back along the negative cable into the ground. And that's going to prevent the Raspberry Pi from getting overloaded. If you leave out the resistor, there is a potential chance that if the bulb blew or if there was too much voltage going into the bulb, it could feed back into the ground and damage your Raspberry Pi. So that resistor is just going to help protect you. So a very, very simple circuit. We've got pin 18 coming off the T-cobbler, which is plugged into a Raspberry Pi 3, going to the long end of an LED. Then the short end is going to a 330 ohm resistor out to the ground of the Raspberry Pi. Okay.
So far.
So far, so good?
So far, so good.
Right. Makes
So
sense.
notice, no soldering involved. Prototyping today,
Yes.
just so that you can see how it's done. You can solder it, you can put it into a nice little case, do whatever you want. We're using an LED, you could use a relay.
Right.
In place of the LED, get a 3.3 volt relay, and then you can trip a 110 breaker and turn on a big sign.
Live
strobe
now.
light.
Strobing the Cat 5 on the air.
Whatever you want to do. Okay, first thing we need to do on our Raspberry Pi. Now, I've already done this, but I want to show you just because it is necessary. We need to install a program called Git, and Git is going to allow us to download repositories, and we're going to need that functionality. Apt install Git. And you might want to do an apt update first. You can see Git is already the newest version on my computer, and that's exactly what we're looking for. This is a clean vanilla Raspbian Lite installation. So I've just installed this on a Raspberry Pi 3 Model B. Okay, so next I need an application that will allow me to communicate easily with the GPIO. I don't want to get into creating registers and making all kinds of crazy stuff. There are tools that are out there that make it a lot easier to communicate with that general purpose input-output of the Raspberry Pi, which are all those pins. So you've got 40 pins, right?
Yeah.
You can plug into those and do all kinds of things. We can program what we want to do with them.
Right.
This is like the most basic thing, but we're going to be tying it into our API, so it makes it a little bit more exciting. So the tool that we're going to use, I'm just going to go into my temp folder, which resets, removes everything that I put in here after a reboot, so it's a good spot to do this. Git clone, so remember I installed Git, and I'm also super user. I have to be root for these things. So if you're not already root, the way to do that is sudo su. All right, sudo su, and then cd/temp. Why do you have to be root? You have to be able to access the hardware GPIO. You have to be able to access the folders like user local bin. You don't want permissions issues, but particularly you need to be able to access the GPIO, which requires root access. So we're going to git clone, and then we want to grab this tool called wiring pi, which we're going to get from git :// and remember, I'm going to put all these commands in the notes below. Dragon.net, not dragon.net, and then / wiring, and be mindful, it's a capital P on pi, wiring pi. Destination path, wiring pi already exists. Oh, apparently I already tested this. I'm going to remove it just so that I can show you from scratch. Okay, so try that again. There we go. Okay, so now CD wiring pi with a capital P, or I just type WI and then hit tab, and you'll see a couple of files here. But we need to build this, so we just go / build, enter. And you wait. And you wait. And assuming you are not on a Raspberry Pi Zero, it will happen quite quickly. Now, if you type GPIO, you'll see that it actually gives output. I don't have to be in that folder. I can be anywhere. GPIO, and it gives output. Okay? So now I can actually start utilizing those GPIO connectors on my Raspberry Pi,
right,
which are connected to a T-cobbler. Again, it's just a convenience thing. You don't have to have a T-cobbler. You can solder things to your Raspberry Pi, but this is just a really easy way to prototype. So the first thing I need to do, because all GPIO pins are input set when you first boot it, we need to set that GPIO, which is, do you remember what number we plugged it into? You can see it if you're looking on the screen there.
Oh,
was
my.
it 13?
Number 18.
18.
Number
y'all
18
see
is
that?
3.3 volts output when it is enabled, or they call that high. Okay? So on pin 18, I have to change that from input to output. So I go GPIO-G mode 18, that's the pin number, output. Enter. Now my GPIO pin is an output pin instead of an input pin. Now I want to turn on the light just to test it, because I want to make sure that it's working and
Sure.
I've wired everything correctly. So GPIO-G right, pin 18, and we're going to put 1. 1 sets it to high, aka on, aka 3.3 volts. It's going to be a little less because of that resistor. So now when I hit enter in 3, 2, 1,
Yay!
Oh, it's on.
there we go. Sweet. Now, similarly,
Does that excite us?
I know, right? So similarly, I can remove that 1 and add a 0, and it will turn it off.
Oh.
Yes.
Yeah. Aw, Jeff.
Hey!
Simple things, folks. Simple things.
This is what happens when you take a week off.
So now you say,
It's like, light bulb!
yeah, ooh. So now you say, well, what can we do with this? Well, Category 5 has a live API. It just responds with either a 0 or a 1. 0 if we're off the air, 1 if we are on the air. You'll find this at live.cat5.tv/API/realtime, and you just pull that using wget, using curl, whatever you want. So if I do that, so if I do wget https:// live.cat5.tv/API/realtime, and then it gave me a file called realtime. I'm going to cat that. And you see it's 1. Do you see that?
Yes.
Maybe it would be easier if I did it this way. If I wget, and then instead, I'm going to output to the screen instead. So wget, I think it's -q-o-1. See the 1, and then it says root?
Mm-hmm.
And echo, no, and echo, quote, quote, that'll help. There, 1. If we were off the air, it would be a 0. Okay? So this command is going to tell us whether we're on or off the air. Now, incidentally, there's another helpful tool on our API called test. And it will automatically change between on the air and off the air without you having to do anything. See how it was 1 first and then it turned to a 0?
Right.
Every 30 seconds it changes. So that's a great way to be able to test our code before we move it over to real time so that we can see if everything is working. So I've created a repository for you. Let's go into home/pi and let's go git clone https://github.com/cat5tv/cat5tv-live. We're going to clone that into our /home/pi folder. Now it's there. CD Cat5TV-live/SH, and you're going to see a couple of little tools there that are going to be very, very helpful for us. So in just a couple of moments' time, we're going to learn how to tap into that API and turn on and off that light, depending whether or not we're on the air.
So cool.
Stick around.
Whether you shop on ThinkGeek, GearBest, B&H Photo Video, eBay, or Amazon, or even if you want a free trial of Audible, you'll find the best deals and support the shows we produce by simply visiting the shopping sites you already frequent by using the links on our website. Visit category5.tv/partners for the full and ever-growing list, and help us create more free content like this show. Thank you for shopping with our partners, and thank you for watching.
Welcome back to Category 5 Technology TV. We are turning on the lights. Sort of. No, but that's what we're covering. We're taking a look at a Raspberry Pi. We're using the breadboard, and we're showing you how to use a little program from Category 5 to turn the light on when we are live on the air.
And you know what? It's really just a proof of concept.
Yes.
Because the whole idea behind this demonstration is just to get you excited about, hey, you know what? I can actually do some things with this. You could use grep, and you could find out if the school buses are canceled in your area.
Right.
And you can have a little light go red if the school buses are canceled. Get the kids excited every morning if the light is red. You know, you can do whatever you want to do. You can use all kinds of tools, and what you do is really up to you. And we're just working with one GPIO pin.
I almost feel like this could be used as some sort of like a Pavlov's dog kind of situation. You know, just putting lights around your house and randomly turn them on. It's like, oh, it's dinner time. Turn it off. Oh, it's dinner time. You know, the next thing you know, you flick a light and everyone's like salivating.
So practical.
That's right.
So incredibly practical. Okay, so we mentioned about our API, and our API just tells you whether or not we are live, and it looks a little something like that. So we're off the air, 0. See how it returns a 0? I'm using the test API, see? So if I keep running that, it's eventually going to change to a 1.
Right, because it switches every 30 seconds.
Yeah. And I see that some of it gets cut off there on your screen. Don't worry about it. You can see what that, as it scrolls up. Oh, it's taking a little longer. 1, we are on the air.
The light didn't turn on.
That's because we haven't coded it to yet, Jeff.
Oh, I just want to see the light.
GPIO, right, number 18-1. There you go, Jeff.
Yes!
There we go.
There you are. Okay, so that's the thing. We want to, okay, first of all, we need to create some kind of intelligence to create a loop and say, are we live or are we not live?
I almost feel like there was a slam on me because I wanted to see the light. We need to create some sort of intelligence.
So here's a simple tool that I just whipped up for you. You can see that it's got both the APIs. We've got the test API that toggles every 30 seconds, and we've got the real-time API. Then we've got a quick loop, and here's what we're doing. Now, we've already learned some of these things. So we're setting the live variable in Bosch using wget and then whichever API we're using, and then we're outputting the response of that rather than downloading a file, okay? So live is going to become either a 0 or a 1. If live is 0, say we're off the air. If live is 1, say we're on the air. And if it doesn't know either way, if it's not a 0 or a 1, it will say unknown, and then it will output whatever it output. Maybe my server's offline or something like that. Then it will sleep for 10 seconds, which means the loop is going to wait 10 seconds before going again. And the first thing it does when it restarts the loop is it reloads the API to check what the status is. So if I run this code, we can see we're off the air. No, we're not. This is the test API, right? And it's going to keep checking every 10 seconds. We know that the API is going to change. The test API changes every 30 seconds. So the most we're going to see is 3 off the airs and 3 on the airs, and that's going to loop.
Right. Okay. And so when you've got something like this, could you use something other than a light? Could you have like a little bell that dings, or could you?
Sure, you could.
Could you program like your Alexa to say Cat5 is on the air or something like that?
You could do any number of things. Now you see we're on the air because 30 seconds have gone by, and so it's on the air.
Right.
As I mentioned, you could use a relay in place of an LED. A relay will take a small voltage, like 3.3 volts, and allow you to use up to 210 volts or something like that.
Right, okay.
So you can have a 3.3 volt trigger, flip the relay, which connects the connectors for the 110,
Okay.
and then turns on whatever you want. Or, that's the GPIO scenario anyway, so you can really do anything. As far as communicating with Alexa, that's a whole other thing. That's not something that we're doing here with
No, fair enough.
That's certainly not something we do with
I
GPIO.
didn't know if the program would, if you programmed it to that it would go that far.
You could make it do any number of things, but all this does is it gives a 3.3 volt signal, or it turns off the 3.3 volt signal.
Okay.
An LED is the most simple way to demonstrate that is actually taking place.
Right.
Yeah.
Okay.
But I think a relay really opens it up to new possibilities. So now we see that loop is happening. We're off the air. We're on the air because it's the test API. Now, if I switch that instead to the actual real-time API, so comment out the test API, and run that, we're going to see that every time it's going to say that we are on air. Because right now we're broadcasting, so we are, in fact, on air. So
Right.
that's what it's going to output. So I've created a second tool which just takes that to the next step. So again, it uses everything that I've already demonstrated and shown you here to be able to do what we want, which is inevitably turn on the light, turn off the light, depending on whether or not we're on the air. So I've set the GPIO pin as a string so that you can change that if you want to a different GPIO pin. I've set that to pin 18. Then I'm saying if the GPIO executable exists in user local bin, then we can continue. If not, it's going to warn us you haven't installed wiring pi yet. Okay? Because remember, that was one of the first things we had to do.
Right.
Then we need to set the pin for output. We already demonstrated that, but we're using the string. Instead of having to put 18, we're using $pin. So that is now an output pin at the beginning. Notice there's no loop yet. Okay? Because we don't need to turn it output, output, output over and over again. Now, clear the light state. If it is on, we're going to turn it off the first run. And we already learned that command as well. Then we start our loop. And this is exactly the same as the loop that we just looked at, except for one thing, and that is that I've added the GPIO statement. So we grab the API from whichever API is selected, then we see whether it is 0, in which case we say off the air, but then we also turn off the light.
Okay.
Right? We're writing to the pin 18, 0. If it's live, so 1, we say on the air to the terminal, and then we take pin 18, $pin, and we set it to 1.
Simple enough.
Okay? Then we sleep for 10 seconds. Now, let's see what happens. So you see on the screen, I'm going to run that GPIO.sh. Enter.
Oh, the light's on.
We're
Because
live.
we're on the air. So now, remember, we're using the test API. So every 30 seconds, it's going to turn on or off the air. It's going to respond with either a 1 or a 0 every 30 seconds. So right now, we're on the air. So the device that you've created now, the light is on.
Right.
It's time for Category 5, time to make the popcorn, or whatever it is that you
the time
happen
to
to
make
use.
popcorn has passed. You need to get to your feed.
Wait for it. Wait for it.
Oh,
we're going to
yes.
go off the air now.
No, we're not.
Yeah.
I don't want to go off the air.
Here it goes.
Oh!
There it
That
goes.
would be a
Did you
great
see?
way to end the show.
Yeah. Go. Zoom. There you go. So that's as simple as it is. Really, really simple programming. Really, really simple circuit. You can build something like that, and it takes you 10 minutes, realistically.
Sure.
Take my code. Study it. I mean, it's really, really simple. I just whipped that up before the show just to be able to demonstrate it for you without making too many mistakes here on the air while we're live. And it works great. And it could be used for so many different things.
I like
That's
it.
cool. You know, I mean, I'm truly sitting there going, I'm picturing like building a house and wiring lights all over the place that run off a Raspberry Pi.
Why not?
Yeah.
So you could be in the kitchen, you toggle a switch, it's like, ooh, dinner's on, or, all that kind of stuff, so
Yeah.
that all the bedrooms just have this little light that goes off, and kids can be doing homework, and they're like, oh, dinner's ready.
So this is where we need to tell you about voltage, and
Well, yes.
you don't want to pull too many volts off of the Raspberry Pi.
Right.
You're going
Fair
to
You
need,
can't hook it up to your microwave to pop the popcorn. No.
No.
but with a relay, again,
Yes.
you can then use like a 4 amp power supply, plug that into the relay, then plug the relay into the 3.3 volt
Right.
GPIO, and you can have the relay trip to trigger a 12 volt 4 amp circuit.
Right, exactly.
And it does whatever you need.
Dennis Kelly asks, and I think I know the answer to this. So, is there a way to make it come on 15 minutes before the show? The truth of the matter is, we kind of go live a couple minutes before the show anyway, right?
We do, yeah.
So, it would be fine.
So what's interesting about this is the moment I push live on Telestream Wirecast, our server database creates a variable in our server. It's a session variable that says we're live.
Yes.
Right.
So it automatically creates all the feeds and puts everything up and does all that and does everything that happens.
Yeah, I get a little pop-up on my screen.
There you
see?
go.
Right.
Beep,
So
we're live.
what you will get in that moment is the light will come on, not when we start, hey, welcome to Category 5. No, as soon as we push that we're live button and we're streaming to the web, it's usually about 15 minutes before the show. That's going to happen. So try the circuit, and if you try this simple circuit and the simple software that I've provided for you to get started, we'd love to see your pictures. We'd love to hear from you and know how it's worked out. And make sure that you've got it near the TV next time you're watching Category 5 TV when you're watching live. And if you're not familiar with our live schedule, it's every Wednesday night at 7 o'clock Eastern Time. That's when we are actually broadcasting live. If you're watching it elsewhere, you may be watching like a recording or something else.
Exactly.
So.